Hello there. My grand design, my opus magnum, the project I'm going to be working on through the entire winter, is currently entering a stage where I am building wheels. This is an Alex Rims Evo Super Comp, so 3 marketing buzzwords, so you know this is a great rim. And I'm going to lace these to some spokes, which I'm going to discuss later in another video, and the X-Cobra hubs I discussed or reviewed some weeks ago. Anyway, today I want to talk about rims, because this is one of the most underappreciated part of a bicycle. Or is it? Doesn't matter. Sounds nice. Anyway, this is an interesting part of a bicycle because, well, it seems very simple, but it's actually quite complicated and well thought item. You can see that the scribble tag has been deployed because I'm too lazy to learn OBS. So let's start. Rims are commonly made out of 3 materials, although currently I believe that 2 materials, the third one is kind of forgotten now. I'm of course talking about steel because, well, it's the worst material to make rims of, but for decades until aluminum became commonplace, steel was the material of choice to make rims because, well, it was cheap, although quite heavy. However, since the time that mountain bikes became popular and rims became beefier, you could make quite light rims out of steel because road bikes don't need beefy rims. Anyway, currently the most popular material for rims is the aluminum, like this one. And well, it's not a coincidence that this is the most popular material because it has properties that make it perfect for making such a shape. Because aluminum can be easily extruded in a long lengths of a profile, and you make a rim by simply taking that kind of profile, cutting it to length, and then simply bending it and joining it at the end. So, it's a perfect material, the end product is very light, it's very stiff. So, the most popular material for now, at least for rims, obviously, is aluminum. However, recently another material has become, I wouldn't say popular, but we are now aware that it exists, and it's of course carbon fiber. The difference between aluminum and carbon fiber is that carbon fiber is obviously much lighter. However, these 2 materials are also different in the way they, well, work. Of course, carbon fiber is lighter, so you can make a lighter bike. However, it is not a perfect material for a rim because, as with all composite materials such as carbon fibers, Kevlar and whatsoever, the main problem is that their failure mode is catastrophic, which means that if a carbon rim is to fail, it's going to fail in a way that's most likely going to explode in some sort of way without warning. On the other hand, aluminum usually, when it breaks very elegantly. It's going to bend and then it's going to break, so you've got quite a bit of a forewarning. Note, however, that at least in a competently made carbon wheel or carbon rim, it takes much more effort to break it than to break an aluminum rim. So you're going to find much more failed or damaged aluminum rims than the carbon ones. However, the carbon rim is most likely going to, well, explode on you. So, you know, you're buying something expensive, so you might as well be aware how it works. By the way, this is also true for frames, but that's another story. I have a spoke, and I'm going to be speaking using this spoke and pointing at things here. I have a spoke, and I'm going to be speaking using this spoke and pointing things here. So, this is a cut through a typical aluminum rim. This one is a triple chamber with a hook, with a volley, and with a single eyelet. What are those parts of a rim? Well, The hook is the edge of a rim here, which is a part that the tire uses to essentially, well, hence the name, hook itself to the rim. Once the tire is pumped to its working pressure, the pressure is going to push the edge of the tire, its bed, onto the hook, and it's going to create a very secure connection to the rim. Recently, however, a concept of a hookless design became commonplace. I have scribbled a hookless design here. And the essential concept is that you don't really need a hook if your rim is shaped in a way that the tire sits securely on the material of the rim. Hookless design is not something that's better than a hook design, it is less secure. However, hookless rims are usually carbon rims, and making a hook in carbon fiber is usually, well, it is possible. It's not really well done. It's not something that is easily made in carbon fiber, because making this kind of a chamber, this embossment, this shape, is very difficult if you want to make it out of, well, a piece of cloth, essentially, that's sprinkled in glue. Anyway, hookless rims, you will always find them, or usually, I'm sure there's someone who makes them in aluminum. Hookless rims are usually carbon fiber, and you shouldn't be afraid of them, but you should be aware that they don't hold the tire as securely as a hook design. Interestingly, however, hookless tires or hookless rims are usually, well, for tubeless. Go figure. So, this is the hook, this is the hookless, which we just discussed. So, sometimes when you are dealing with or reading about a rim you intend to buy, you will find it in its description that it's described as a multi-chambered design. What does that mean? Well, the profile the rim has been shaped from can have, well, multiple cutouts or multiple shapes if you cut it through. And if you count the cavities inside of it, you will find that there are multiple of them, obviously. And the number of those cavities means the number of chambers this rim has. This particular design is 1 to 3 chambered. You will find 5-chambered rims, you will find single-chambered rims, which are, I think they are most popular, irrelevant. The point about chambering is that this creates a good design in the rim, which essentially makes it a bit stiffer. However, obviously, it makes it heavier. Now, this is an eyelet. As you can imagine, rims are usually used on the bicycle rims, on bicycle wheels. And bicycle wheels tend to use spokes, like this one. So, a spoke, or actually a nipple, is placed here, and it pulls with quite a significant force through the rim. So, some rims, I think even majority at this point, have a stainless steel eyelet, a rivet or some sort, which holds the nipple. This is being done for one very specific reason, since the force at which the spoke pulls from the rim is very significant. The thinly walled rims tend to crack here when they are used in a significant period of time. So in order to avoid this problem, a steel insert is done on the... Alright, so let's discuss eyelets. As you can imagine, if you saw a bicycle wheel, and I presume you did because you are watching this video still, bicycle rims tend to be pulled from rather awkward angle, because at 90 degrees or something close to 90 degrees here, with a quite significant force. For example, I think DT specifies that 1200 newtons is a maximum force allowed to pull from the rim. And that's quite a lot. On the other hand, a spoke nipple is quite small, so there is a very little surface to spread the load over the higher area, which means that if a rim, or if a nipple is pulling the rim, with a maximum force, quite a bit of pressure builds. Let me draw this. Quite a bit of pressure, if we assume this is a nipple, quite a bit of pressure builds here and here. And this pressure, repeated over hundreds upon thousands of cycles, which is rotations of the wheel, usually ends up with the rim cracking here. It creates quite an interesting pattern. You can always often see it in old wheels, especially on the lightweight old wheels, because if we suppose that this is the rim, we see it from the top. This is the hole, and you will see that there's a crack in both directions, away from the spoke hole. In order to avoid this problem, what's being done? Well, eyelets, obviously, which is making the hole bigger, which makes the load spread over higher area, and then filling the difference of the nominal hole required to push a spoke through the rim with a stainless steel insert. The stainless steel insert is much more resilient to the forces at which the spoke is going to pull it, and it spreads. I'm going to talk to you after I'm done with the video. And it spreads the load over a higher area, which puts it below the cracking limit of the rim, which essentially increases the longevity of the rim by quite a higher percent. Obviously, eyelets add weight, and you are going to find that they are available in two particular designs. The one design is a single eyelet, like here, which I drawn originally, and the other design is a dual eyelet design. A dual eyelet design, which is built somewhat like this. Here, here, and here. Essentially, it's a longer stainless steel tube, which is riveted onto the rim, which rests on both walls of the rim, which obviously spreads the load or even further area, which makes the wheel even more resilient. Although for majority of cyclists a single eyelet design, single wall eyelet is sufficient. However, if you're doing some sort of downhill riding, dual eyelets might be worth it. Anyway, so this is the eyelet, these are the chambers, this is the hook. Now, a very important part of the design of a rim is the valley in the inside. You see, tires, the tire bed is actually the wire here isn't really flexy, as it shouldn't be, because the tire wouldn't work anyway. So, in order to put a tire on a bike, you need to somewhat force it through the wall of the rim, and since this doesn't flex, it would be impossible. So how is it done? Well, you are essentially reducing the diameter of a rim here. You are putting the wire in this particular place, and you're pushing the tire onto the wheel. This allows you to navigate the tire onto the wheel, onto the rim, from one side, then from the other, and then you can, as you add air to the inner tube, or as you're pumping your tubeless tire, this tire gets spread and it's going to jump and rest on the walls of the rim. The valley here is simply a way to allow you to put your tire on your rim. Now, obviously, if you want to remove the tire from the wheel, what you're doing, you're letting go of the pressure from the inside. Once it's flaccid, you are simply pushing the wire, the sides of the tire, into the valley, and you can then simply take out the tire. Alright, so let's discuss how rims are being joined, because that's quite important if you're buying a rim for a tubeless setup. Obviously, a rim started as a length of a straight aluminum profile, and once it was bent into shape, you had to join it here. There are two methods of doing this. The one that was used here is the simple one. It's simply a sleeve of some sort of material that was pressed into the chambers of the profile, and once it was in one part, it was simply the other part was simply pressed onto it, and it was punched here to ensure that this connection is secure. And the other way of doing this is doing a sleeve or not, and simply welding this part to create a smooth transition. The difference between those two things is that the sleeve on its own is a bit weaker than welding it, because there's not the continuation of the material here. Although for majority of riders that's pretty much irrelevant, or I guess that if you're doing some sort of gravity riding, that might be interesting, that might be important. However, the difference is that if you're making a tubeless setup, purely sleeved rims might be more difficult to seal, because there might be a minimal air gap between the parts of a rim, so obviously your air is going to escape through there unless the sealant is going to be able to seal it. If you're buying something knowing that you're going to be going tubeless, search for welded rims. Alright, we talked about technology, now let's talk about religion. In the recent years, especially around the time when mountain bikes experimented with very thick tires, and I think that in the last 10 years the average tire size in the mountain bikes went from 2.1 or 2.2 inches to 2.5, 2.6, so that's quite important. The importance of width of a rim became important. What is the width of a rim? Well, it's the distance between a hook and a hook from the other side. And if you're going with hookless rims, obviously the distance between the walls of the rim. Importance of the width of a rim is that the hooks create pivot points for a tire to travel from one side to the other. And if you're riding rather lower pressure, having those points wider makes the tire float a bit less. This is quite important because, lower pressures usually means higher grip, and on a mountain bike you want higher grip. On the road side of things, you've got another problem, because road bikes are now using wider rims, but the reasoning for that is different, because on a mountain bike you want stability, on a road bike you want aerodynamics. Because road bikes are at the part of the revolution that you simply can't improve them by putting more technology into them. You need to get smart, and all your bonuses or your progress is going to be minimal. However, what's the thinking? As in the years past, the road tire would be something like this, and the rim would be something like this. This transition isn't really smooth. So the thinking now is that the road tire and the road rim must create a very smooth and aerodynamic shape, tear-shaped, which usually is something like this. This is the tire, this is the rim. Obviously it's a deep section rim, because what else? And the transition between the tire and the rim must be as smooth as possible. So now road bikes are using also wider tires and wider rims. The reasoning is simply aerodynamics. This creates a very smooth shape to air to flow through, and you are now 0.7% faster. Alright, so when dealing with road bikes, you don't really need to be bothered, because if you're at this stage of riding road bikes, you're probably riding some sort of a system wheels with a system tires, or everything is thought of for you. However, when it comes to mountain bikes, you have quite a bit of play there. So, is it worth to use wider rims? It's a religious question, as I said, because you can use a heuristic that each 3 millimeters of width of your rim equals approximately 1 millimeter of a diameter of your tire. Moreover, as the rim gets wider, the tread on the tire gets flattened a bit and becomes a bit more aggressive. The side knobs are going to engage the terrain faster or at a lower tilt of the bicycle than on the narrower rim. So that might be a bonus for you. However, obviously wider rims are also heavier, and lugging extra, I don't know, 500 grams up a mountain might be a problem for you. You know, trade-offs. Anyway, I think, and it's my opinion, that having wider rims is something you should look for, especially if we consider something I'm going to talk in a few minutes. But don't go overboard. For example, if you're on the market for new wheels, consider something that's wider than what you have. But if you are searching for something to upgrade on your bike which works perfectly fine, then changing from, I don't know, 35 millimeters to 38 millimeter rims, there's no point in doing that. You're not getting much because the difference is simply minuscule. This is the difference you're getting. However, changing from, for example, 20 millimeter to 35 millimeter might be worth it, especially if you want to use bigger meatier tires. Alright, so how wide your rims can be to fit your tires? Now, this is also a somewhat religious question, but it has certain engineering underpinning. And that's quite simple. If you use a very simple heuristic, your rim has to have a width between 50% to 110% of your tire width, which means that if you're using 40 millimeter tires, your rims should be between 40 and 20 millimeters. However, the thicker the tire, the smaller the rim can be. For example, if you're riding something that, I don't know, 2.6 inches, you should probably aim for something 50 to 70, 65% of your tire. However, if you're on a road bike and if you want to chase those minuscule gains, then you want to use wider rims and tires that match them. So 28 millimeter tires usually calls for outside of approximately 20, 22, 28 even millimeter of a rim. So 28 for 28 millimeter tire, that's 100%, so that's quite wide. I think that I heard somewhere that if you want to have maximum aerodynamics of your road wheels, then you should use rims that are wider by 10% than your tires. Go figure. Alright, so what's the conclusion here? Well, the conclusion is simple. If you're riding a bicycle and you're not racing, you don't have some specific need. What you actually need is a triple chamber or a single chamber aluminum rim with a single eyelets and amount of holes and a valve hole that fits whatever your requirements are, because that's essentially 90% of what you're going to need. Oh, and the width should be about 70% of the width of your tire. The bigger your tire, the less you should be bothered by the width of the rim. So if you're riding something like 2 inches, then use something like 25 to 30 millimeter rim. If you're riding something like 28 millimeter road, use something that's 20 to 25 millimeters outside diameter, so the inside is going to be slightly lower. And that's about it. And it's not really a complicated problem. It starts to get interesting if you're going to the extremes. For example, for a tandem you would need a double eyeletted rim. If you're using 4-inch tires, then you need very wide rims. And, well, if you're really heavy, you need something more robust. But that's about it. In my experience, in a properly built wheel, the quality of the rim you're using isn't really important. I've been doing enduro on a well-built wheels, because I built them, on trekking wheels that cost 20 bucks and nothing happened. So, you know, wheels are an interesting part of a bicycle, because they are the quality and the life you're going to get out of them is much more based on the engineering and the quality of the wheel build than the engineering or quality of the components involved. I have wheels that are built on a $5 rims and $10 worth of spokes, which have thousands of miles on them and nothing happens to them. So, you know, engineering or quality of a wheel build is much more important. In essence, good aluminum rim with a single eyelet plus stainless spokes with a rolled thread, J-bend, because who cares, build it well and your rims are going to be, or your wheels are going to last forever. So I think that's all I have to say about rims. I'm going to bloviate about spokes in the next video, because I'm going to be building the wheel. And then we're going to move to another subject, which is a surprise. And it's a surprise because even I don't know what it is. And of course, if you enjoyed the video, consider subscribing if you haven't yet. If you think that was interesting, share it around. I'm always happy to see that view count go up. Essentially, my self-respect is based on that number. I'm joking. No, I'm not really. And, well, I hope to see you on the next video.